Good afternoon, everyone. My name is Mark O'Malley, and on behalf of Maritime Reporter and MarineLink.com, I would like to welcome you to the RSC Bio Solutions webinar, Complying with New EPA Lubricant and Cleaner Requirements for Marine and Offshore Industries. RSC Bio Solutions is an affiliate of RSC Chemical Solutions, 90-year-strong chemical manufacturing company well known for its flagship brands in industrial and automotive distribution channels. RSC Bio Solutions was established in 2010, is headquartered in North Carolina, and leverages the formulating, manufacturing, and distribution capabilities of RSC. Focused on helping customers save money, time, and reduce business risk by providing high-performance lubricants and cleaners that are safer, non-hazardous, and environmentally responsible to solve prevalent industry problems. RSC Bio Solutions has grown as a result of the acquisition of TerraSolve Technologies and its improved Envirologic lubricants brand, as well as organic growth with cleaners and degreasers as a licensee of SafeCare Technology and GreenZorb absorbance distributor. RSC Bio Solutions is focused on providing solutions to prevalent industry problems for solid waste and utility fleet operators, wind power, marine construction, transport, and offshore oil and gas operations. During the presentation, we encourage you to ask questions using the questions panel on the webinar window. At the end of the presentations, we would like to try and answer as many questions as possible. And now, I would like to introduce our presenters, Lisa Owen, the Vice President of Sales and Marketing, and Mark Miller, the Executive Vice President of Business Development for RSC Bio Solutions.
Thank you, Mark. United States Environmental Protection Agency's 2013 Vessel General Permit changes are designed to address a key marine industry challenge of lubricant discharges into aquatic environments and the resulting hazards posed. The cleanup costs, environmental costs, and potential fines associated with addressing discharges are also incentivizing companies to look for ways to help reduce the costs and the impact of spills on the ports, coasts, and waterways in which vessels operate. The 2013 Vessel General Permit cites a 2010 presentation of Dr. Dagmar Atkins, who estimates annual lubricant discharges in the marine environment to total 10 to 16 million gallons per year. That's roughly equivalent to 1.5 times the size of the Exxon Valdez oil spill annually. The annual costs in terms of response and environmental damage worldwide is further estimated by Dr. Atkins to be roughly $322 million, and 10% of that is attributed to discharges in U.S. ports totaling $31 million per annum. It should also be noted that these cost figures exclude fines and damages that are levied at by federal and state authorities, and it also excludes catastrophic oil spill event costs, such as an Exxon Valdez or a BP Deepwater Horizon. So the U.S. EPA Vessel General Permit came into effect in December of 2013. It's applicable to all commercial vessels greater in length of 79 feet. For new builds, it goes into effect at the time of construction. For existing assets, it's effective at the next dry docking of the vessel. It's applicable to all vessels that operate within 3 nautical miles of the U.S. coastline, as well as Great Lakes and inland waterways of the United States. And this Vessel General Permit is recommended, although not yet mandated, for vessels under 79 feet. So what does the VGP require of vessel operators or applicable vessel operators? First and foremost, they require environmentally acceptable lubricants, known as EALs for short, to be used in all oil-to-sea interfaces unless it's technically infeasible to do so. And we'll explore here in just a second what is meant by both EAL and technical feasibility. The permit also requires applicable vessels to use cleaners and detergents for all deck washdowns that are phosphate-free and non-toxic. And the permit also requires applicable vessels to maintain the non-sheening rule that was introduced back in 1990 as part of the EPA Oil Pollution Act. So what does the VGP mean in terms of oil-to-sea interfaces? Essentially, it's any component with the potential to leak lubricants in an oil-to-water interface. It includes oil-lubricated stern tubes. It includes on-deck, underwater, or submerged machinery. Specific applications such as rudder bearings, controllable pitch propellers, thrusters, fin stabilizers, dredgers, grabs, propulsion pods, and even grease-coated wire ropes. The Environmental Protection Agency defines VGP-compliant fluids as those that minimize negative impact on aquatic environments as measured by three key characteristics: rate of biodegradation, aquatic toxicity, and bioaccumulation. Fluids must be readily biodegradable products which completely break down to carbon dioxide, water, and mineral salts within a specific time frame. According to ASTM and OECD 301B test standards, they must break down by 60% within 28 days or more. So 60% or more within 28 days. In terms of aquatic toxicity, fluids must be minimally toxic to aquatic organisms, which include daphnia, algae, and fish. And aquatic toxicity is strongly influenced by additive selection and loading, particularly around things like anti-wear properties of lubricants. And not all lubricants will qualify as minimally toxic. Some biodegradable lubricants may not qualify as minimally toxic. Fluids must exhibit very low potential to bioaccumulate or build up chemicals within the tissues of organisms. And so it's only those fluids that exhibit an extremely low potential, which are included in the definition of an EAL. According to the EPA, VGP compliance can be demonstrated through independent laboratory testing regarding these three key characteristics of a fluid, and this is often referenced as self-certification, or it can be demonstrated through one of 5 European labeling programs that are accepted by the EPA, which include Blue Angel, Nordic Ecolabel, the Swedish Standards Institute, OSPAR, and European Ecolabel. There are also other certification programs under consideration, including EPA's own Design for the Environment and Lloyd's Register. While there is no preference for self-certification or independent labeling, there is a difference, and particularly with some European labeling programs, there tends to be an advocacy or bias towards bio-based content, and it's important to understand that in all cases there can be trade-offs between bio-based content and performance. And vessel operators can be faced with far shorter fluid life from a solely bio-based lubricant, and that can be measured in months versus years. So our advice in following or complying with EPA's VGP is that you really ensure the product data sheets and MSDSs for the EALs you're considering clearly state VGP compliance, and that the suppliers back that up through testing and certification. So What does technical infeasibility mean? Essentially, if no OEM has approved EALs for a specific use or application, then you have a technical infeasibility. If there are no available alternatives manufactured which utilize EALs, for instance, grease-coated wire ropes, then there's a technical infeasibility which can apply. If EALs are not available in a port in which a vessel calls, then a technical infeasibility can apply. And if a vessel has not yet had its first dry dock since December 2013 when this permit went into effect, then in fact it can be a technical infeasibility. But what we would say, and Mark will cover here shortly in more detail, in most cases there are EALs approved for applications and fairly broadly available in the market. So, what does the permit say about a vessel operator's obligations and reporting requirements? Any noncompliance which can endanger the health or the environment must be orally reported within 24 hours of the time the vessel operator becomes aware of the noncompliance. And written report is required within 5 days of the awareness of circumstances. And on a going forward basis, the EPA, via the Coast Guard, will require documentation on compliance or non-compliance in the vessel's annual report and log as effective February 2015. So that's a little bit of, key overview of the VGP, and now let's transition to my colleague Mark Miller to identify key technical and regulatory considerations in EAL selection, common misperceptions about EAL, and solutions for the marine industry.
Thanks, Lisa. Well, I want to talk a little bit about the many viable, environmentally acceptable lubricant alternatives out there. We all know that many can be more expensive than conventional petroleum fluids, but in reality, viable alternatives can reduce overall costs. What can you do with an environmentally acceptable lubricant? They don't necessarily eliminate a spill occurrence. That's required for your people to take care of. It doesn't eliminate, as Lisa mentioned, the need to report. Discharges are still reportable events. And it doesn't eliminate the need for a good industrial cleanup as soon as possible after a recognized discharge. What it does do is it can offer performance equivalent to or better than petroleum-based lubricants. And it will mitigate the discharge's impact on the environment and also the regulated bodies. Improving performance and productivity will improve profitability. While not all fluids are the same, we know that EnviroFluid technology is much improved. Formulators over the span of many decades have improved their formulating capability, recognizing that bio-based base fluids are not exactly the same as petroleum-based lubricants and base fluids, and working very hard to specifically formulate for designs for marine equipment and that have been thoroughly tested in use and in laboratories. The formulations have improved in terms of compatibility, particularly in terms of components, for example, elastomers, hoses, plastics, as well as compatibility from contamination with petroleum oils and or water. More importantly, we've learned that you have to utilize the right product in the right application. A perfectly good lubricant used in the wrong application can have catastrophic results. Finally, after years of working together with equipment manufacturers, both in testing and development, we have improved the performance. So utilizing the right fluids will pose very little risk to your equipment. And as has been said before, these are not your daddy's biofluids. There's a lot of confusion in the industry regarding environmentally acceptable lubricants. We've seen 4 commonly used throughout the industry that I'd like to address and hopefully reduce and eliminate some of these misperceptions. They are specifically that all environmental lubricants are the same, that HEPR, the polyolefin and related products, are not biodegradable, that technically EALs are technically infeasible, and that they are not compatible with seals and other lubricant materials. What I'd like to do is take each one of these misperceptions and tell you a little bit about the realities behind each one, starting with the first, that all EALs are the same. We should know now that all EALs are not necessarily the same. In fact, the ISO 6743 classifies 4 types of environmentally acceptable lubricants, hydraulic fluids. The VGP also accepts these 4 types. They are classified under the HE, Hydraulic Environmental Classification, and are as follows: the TG, which are triglycerides, primarily vegetable-based fluids; HEPGs, which are the polyalkylene glycols; the HEESs, which are the synthetic esters; and the last classification, or last type of product, is the PAO and related product, the HEPR. RSC Bio Solutions is an independent oil company, and we have access to all these types of base fluids. We are not locked into any particular one, and we can utilize the appropriate fluid in the right application. The first classification of fluids I want to talk about are the triglycerides. We think of these commonly as vegetable-based fluids. They offer excellent frictional characteristics and superior viscosity index as compared to petroleum-based fluids. They do have a shorter life expectancy than would be required between dry docks. Due to its oxidative weaknesses, they tend to break down when they get hot, and hydrolytic instabilities tending to break down in the presence of water. We offer HETG fluids for land application, but more often we recommend the HEPR type fluid for marine application due to its superior hydrolytic stability. The polyglycols are synthetic hydrocarbon-based. They are not vegetable or bio-based. They offer superior fire resistance and are very suitable for use in applications where combustion and flame are an issue. They are traditionally less compatible with conventional seals and filters. They are incompatible with conventional petroleum, vegetable oils, ester-based products. They are hydroscopic, meaning they will absorb water, which can lead to rust and acid buildup. It is best to utilize PAGs where it can be designed or engineered for compatibility in the system with compatibility with the PAG products. The synthetic esters were derived due to some of the weaknesses I mentioned from the triglyceride-based products. Esters are synthesized from triglycerides utilizing a variety of different alcohols and acids, which will form the synthetic esters, byproducts of which are water and heat. When one is able to dry the system or the fluid and cool it, you have a synthetic ester that is extremely oxidatively stable. It offers great lubricity, has benefits of being bio-based and sustainability. The one weakness it exhibits is it's hydrolytically unstable. The problem being is that when water and or heat are added back into the system, the reaction I just described is reversible, forming triglyceride-like substance and excessive acid. We know that acids can deteriorate seals, increase wear, and cause corrosion. So would it be best to use a synthetic ester where you have high temperatures and the access to water ingress is very unlikely? The last classification are the polyalpha olefins and related products. As I mentioned, not all PAOs, polyalpha olefins, are biodegradable, but a readily biodegradable product can be formulated using HEPR base fluids. These are typically synthetic, hydrocarbon derived. They're extremely durable under very severe operating conditions, can offer a long fluid life, thereby reducing the cost of ownership. Another benefit is they separate readily from water, very much like a conventional petroleum product will greatly expand, as a result, will greatly expand the life expectancy of the product. Because they are also hydrocarbon derived, they perform much more similar in terms of compatibility with seals as well as petroleum in the system, and they offer an extremely broad temperature range, operating somewhere between -40 degrees C and 120 degrees C. Many of our envirologic marine products are HEPR type. The second misperception are that these HEPR fluids are not biodegradable. Again, as I said before, many PAOs are not biodegradable. However, there are some that are, and if you're a good formulator, you can make an HEPR fluid that is very highly biodegradable. As Lisa mentioned, in terms of some of the testing by OECD and ASTM, the reference for a readily biodegradable product, as required by the vessel general permit, is a minimum of 60% degradation in 28 days. If it's somewhere between 20 and 60, meaning at some point it will degrade, but not right away, that would be considered inherently biodegradable, and products that do not degrade at all are considered non-biodegradable. Be careful when hearing unsupported claims. I am sure you have all seen and heard people talking about environmentally safe, environmentally friendly, non-cheating, biodegradable. The list goes on, and these are not necessarily readily biodegradable and don't necessarily comply with the VGP requirements. One more time, I said it before, I'm going to say it again, not all PAO fluids are biodegradable, but HEPR fluids can be formulated to be readily biodegradable, and our family of products have been tested in a broad range of testing, biodegradable testing, both through the ASTM and the OECD, and have all been classified as VGP compliant and readily biodegradable, with OECD testing greater than 60% within 28 days. The next common misperception is that all environmentally acceptable lubricants are technically infeasible. And as Lisa mentioned and I talked about a little bit before, there are many technically feasible EALs. As a result of vessel general permit and the industry as a whole pushing some of the component manufacturers to approve their EALs, there is a wide range of products that are technically feasible. Some of these products that are required by the vessel general permit are stern tubes, thrusters, stabilizers, stern ramps, and submersible deck equipment. Other high-risk applications that are technically feasible are watertight doors, davits, ventilator fans, and hydraulic cranes. The OEM approval process is very complex. As you know, several of the OEMs are a little concerned as to giving blanket approvals for EALs. It's a good idea to look for supporting letters and to work together with your EAL supplier and your OEM to get an approval, or at least to determine whether there's a technically feasible EAL that is available. The last of the misperceptions I'd like to talk about today is that EALs are not compatible with seals and other lubricants. And again, this is a misperception that testing and documentation have proven to be wrong. Many types of environmentally acceptable lubricants are compatible with many types of sealing materials. And in fact, depending on the application, we've studied the 4 classes of environmentally acceptable lubricants. with some of the most common marine type elastomers, including NBR, which are the Buno rubbers, the HNBR, which are the hydrogenated rubbers, the FKMs that we affectionately call Viton, and thermoset plastics and elastomers. And we have found under certain situations and certain characteristics that most, if not all, of the EAL fluid types are compatible. We have found, however, that under heat, it can stress the triglycerides, the esters, and the glycols, where they will have less than preferred performance. Water stresses these fluids even more, and we have found in our testing that particularly the glycols with the FKM in high temperatures greater than 100 degrees C or 200 degrees Fahrenheit can cause significant problems and should not be utilized. A little bit about our Envirologic product performance. They are compliant with the 2013 Vessel General Permit. They are mixtures primarily of synthetic biopolyolefins. We utilize the term biopolyolefin to separate polyolefins that are readily biodegradable from non-readily biodegradable polyolefins. We also use some renewable and synthetic esters and a broad range of environmentally acceptable additives that will provide strong anti-wear and extreme pressure properties. These fluids can offer a very long, extensive service life. We have applications that have been in the industry running without change-out for over 15 years. They can offer very high viscosity index, greater than 210, as compared to a standard hydrocarbon petroleum, which would be about 100, can offer a very, very broad operating range, temperature range from -40 C to 120 degrees C. We've actually taken some of our fluids down to -80 C, where they became very slushy, but when they become reacclimated to room and operating temperatures, go right back into its natural performance range and are suitable from performance specifications as if it was a fresh fluid. Our Envirologic gear oils can offer enhanced wear protection and extreme pressure load, having the highest levels of micro-printing protection, which is a problem in heavy-loaded thruster gear systems, as well as wind turbine gear systems. Our hydraulic fluids can also offer enhanced wear and extreme pressure loading with FZG failure loads, or actually passing loads, that exceed the 12-stage pass. These fluids are non-emulsifying, facilitating the water removal in the event of ingress from water, and it's designed to prolong the life of the fluid. You can utilize gravity separation or any of the standard water separatory filters. We offer a full range of VGP-compliant products in addition to our hydraulic fluids and gear oils, which we focused on today. We offer wire rope, chain lubricants. We offer a variety of lithium complex greases, flushing fluids to get that last drop of residual hydrocarbon out there to make it a cleaner and greener system. We have cleaners, as Lisa described very long ago, in terms of part of the Vessel General Permit. It's mandated to use phosphate-free and biodegradable cleaners on deck washing. We have degreasers, as well as adsorbents, in case your folks drip a little oil on the deck. It's a biodegradable wide range of absorbent products that are also environmentally preferable. We've been doing this a long time. This is not our first rodeo, just as these are not your daddy's biofluids. We've been working with a broad range of satisfied customers in the offshore drilling industry, cruise lines, commercial shipping, workboats, and many other applications. So I think that wraps up my portion. I'm going to turn it back over to you, Lisa.
Thanks, Mark. And to our audience today, many thanks for your interest and participation. We've had a great response for the webinar, and we've really tried to help still the VGP. There's definitely a lot to it, and also tried to help you understand key considerations in your EAL selection. We've received a number of great questions during the event, and we would like to respond to those now. The first question is, will the presentation be shared with attendees? The answer is absolutely, and how we intend to do that is we'll be posting the presentation on our website over the next few days, and we will send you a link to that posting. And we would love to have you, pass that along to your associates, and we're certainly available to help you take your company through it if you like. The second question, does RSC maintain a list of EAL products? Well, we just reviewed that right at the end of the presentation, and the answer is yes, and we intend to keep adding to our growing list. From our perspective, we think we have one of the broadest product portfolios that are already BGP compliant, especially when you think about hydraulic fluids and gear oils. Many companies offer one or the other, but few have both, and few have the range of approvals that RSC Bio has. We also have a tech service team at the ready to answer any questions you may have about your specific systems, and on the screen you see how you can reach myself or Mark Miller or our tech service office at the 800 number listed. The third question, I continue to see references to oil-to-sea interfaces in Section 2.2.9 of the new VGP. What about inland river operators, such as towboats and tugboats in brown water environments? That's a great question. And what we would say is oil-to-sea equals oil-to-water. And the VGP applies to all commercial vessels 79 feet or greater operating in U.S. waters. That includes the coastal waters and the inland waters, and of course our lakes. So the VGP definitely applies. The next question, are there common ASTM or other methods that users can submit for testing to see if an EAL lubricant is still valid rather than just replacing, similar to how lube oils are tested routinely for engine oils? Mark, would you like to take that question?
Yes, yeah, there are a wide range of testing in order to determine whether there is a need for retesting from a VGP environmental characteristic. You'd be needing to run the biodegradability test, the ecotoxicity test, and the bioaccumulation test. What you'd also want to do is, in ongoing in-service analysis, you can send your fluid, a small sample, to an independent test laboratory that will measure your standard in-service oil, that will measure the viscosity, the wear metals, the performance chemistry, acid buildup, etc. We suggest very, very strongly that you do this because your EALs tend to be more expensive, and to get the best usage and the best cost of ownership of these products, you want to extend the fluid life. RSC Bio Solutions offers this as a service at no charge to our customers, primarily because we are focused on lubricants and you're focused on operating your equipment, so we want to work with you to ensure complete customer satisfaction.
Okay, we still have a lot of questions coming. Wow, this is great. So Mark, here's a question for you. Our company owns a small fleet of vessels and doesn't have experience yet with EALs. How do we get started?
That's a great question, Lisa, and really it's not that painful. The EPA is not mandating, as we had mentioned earlier in the presentation, has not mandated that everybody immediately has to go change out all their systems to an EAL. So you need to look at it from two perspectives. The easy way is when you have a new build, what you want to do is work with your manufacturer to include EAL specifications. You'll frequently find a total system approach from EALs regarding a seal or elastomer or thruster or some type of stabilizer application in conjunction with specific EALs. So you want to make sure that you're looking for those opportunities. The second opportunity, the second way to look at it is when a vessel is preparing for dry dock, looking at your dry dock schedule, work with your equipment manufacturer for all oil-to-sea applications or equipment to ensure that there's an EAL available. One of the things we're hearing in the field that due to significant increases in demand, and this is from us and other EAL suppliers, making sure that lubricants are available where you need it, when you need it, becomes a bit of a challenge. So the more time you can give both to your equipment manufacturer and your lubricant manufacturer for a scheduled dry dock, the happier everybody will be.
Thanks, Mark. So a really good question. How are EALs priced?
I can't speak for all EALs, but in general, EALs are a little bit more expensive than petroleum-based products. Looking at envirologic products, we try to have our products priced competitively with standard synthetic lubricants and giving similar and comparable performance. We've normally found that our products are less expensive than most of the fluids, other EAL type fluids in the industry. I strongly recommend, regardless of what type of EAL you're using the in-service oil analysis like we addressed during the first question to prolong the life of the fluid for as long as possible, reducing the total cost of ownership.
Thanks, Mark. The next question. How do I choose the right EAL for my system or equipment?
You can help your equipment or your lubricant supplier significantly if you're able to give the following information. The name and viscosity grade of the current fluid within your system, the OEM of the equipment, whether it's a thruster or hydraulic system, if not, what their specifications and requirements are, any of the system temperatures, pressures, and other operating applications, and any specific application specifics that would not be typical for that application. You can also utilize product data sheets that are found on our website, and for us, you can call our technical service specialist at the 800 number you can see on your screen.
Okay, some really good, thoughtful questions around the VGP. So the first question, a foreign flagged vessel does not intend to come to the United States and is not enrolled in the VGP. The vessel goes to dry dock in 6 months and then 3 months later decides to come to the United States and enroll in the VGP. So the question, that was the scenario. Here's the question. Is the vessel allowed to wait until the next dry docking to comply with the oil seal EAL? So, I would say there are two ways to proceed here. One is, you could become compliant before you sail into U.S. waters by, undergoing another change out of oil. Which may or may not be possible. And the second approach is that you could claim technical infeasibility associated with, dry docking schedule and forevermore report it until you become compliant. And what I would say is intent is probably everything here. And so if you have a whole fleet of vessels that are foreign flagged and that's the approach you take, it will probably raise eyebrows. If it's a one-off situation, it's probably understandable. Would you add anything else to that question, Mark?
I would agree with that, Lisa, and I would amplify it by saying many of our foreign flag vessels and fleets are coming to us looking to utilize EALs, even if they're not expecting to come to U.S. waters. In the unlikely event that they do, the additional cost on a new build or a dry dock is very, very small, and it's better to be safe than sorry and to have an EAL in your system already.
I agree. So next question, and keep questions coming. I mean, they're really good. Some of these are quite tough. A stern tube manufacturer has indicated their stern tube seal is not an oil-to-sea interface since there is space between the seal and the water to allow for collecting and draining. Is this acceptable as not needing to use an EAL?
I'm not an expert in that, but we have heard the EPA say in a previous EPA webinar that an airspace seal or space between seals is considered as not an oil-to-sea interface, but they gave the very, very strong caveat that you, the vessel operator, owner, would have to feel very confident that there is absolutely no possible way that oil could get into the sea as a result of using a petroleum-based product on the bearing side of that seal.
So your advice would be?
Well, Lisa, I'm not 100% unbiased, but I would recommend that even where there's an airspace, an environmentally acceptable lubricant be utilized, because I would not want to put my name on an absolute guarantee that said there was absolutely no way that a petroleum-based product could get past the airspace into the environment.
Right, so it's a great insurance policy at very low cost. Okay, next question. Are remote operated vehicles, also known as ROVs, considered water-to-sea interfaces?
You know, we've had that question from some of our ROV friends, and an ROV in particular is not a water-to-sea or oil-to-sea interface, but it is considered to be submersible deck equipment. And submersible deck equipment does fall under the vessel general permit and should be utilizing environmentally acceptable lubricants to comply with the VGP.
Thank you. Okay, a couple more questions. Why are pod makers trying to get an exemption? Is there an issue with rolling element bearings?
Most of the pod manufacturers that we've been talking to are putting themselves into the category of having a separation from the lubricant to the sea interface. There are some EALs that once they begin to break down or hydrolyze that are causing problems with some of the soft metal elements of bearings. We have not found that with the HEPRs.
Okay, and a follow-up question from the same person. Will the shearing action of a plain bearing decrease viscosity over time?
Many different types of lubricants will decrease in viscosity due to high shear. In order to meet ASTM industry standards, you must have a stay-in-grade type performance. So once a fluid will shears down into fall out of grade, the fluid is no longer usable. A good quality lubricant will maintain stay-in-grade viscosity throughout the life of the fluid.
Great. Let's see. Next question. Are there special procedures I should follow when replacing the petroleum oil in the system with an EAL?
That basically depends on what type of EAL you're utilizing and what your level of acceptance for contamination in the EAL uses, or that you can withstand. For example, if you're going to use a PAG ester or a HEPG type of fluid, you must completely drain the system. You must separate all your component parts. You must run PAG through the system until there's no residual product. If you're utilizing a HEPR type of product, they are compatible with petroleum so that there's no decrease in performance as a result of co-mingling these products. And if you can stay below 5% contamination, you should be readily biodegradable and completely compliant.
Okay. Next question. Are hydraulic stern ramps and side port doors covered by the VGP?
Hydraulic stern ramps, I believe, are covered by the VGP as they are submersible products, sort of under the submersible deck equipment, because they have hoses and fittings that do go into the water. The hydraulic side doors are not under the VGP. However, they are, number one, a very simple application to green, and number two, they are a very high-risk application where that can have leaks in the water. My recommendation would be very strongly to change those over into an EAL.
Right, sort of the risk-benefit.
Exactly.
It's easy to do and low technical risk.
Well, you don't want to be, the whole purpose behind the VGP is to reduce negative impact on the environment. As we talked in the as you shared with the very first slides, the cost to the environment, the financial cost, the environmental cost of petroleum leaking into the water is a major problem, is a major expense. So the spirit of the Vessel General Permit, as well as the direction of the industry, is to use as environmentally preferable products as possible.
Okay. Do you and Mark perform on-site evaluations and assessments? Well, I think that bodes well. Yeah, the Lisa and Mark show coming soon to a theater near you. What I would say in all seriousness is we have a fantastic sales team and technical service team, and we do a lot of on-site evaluations and assessments and recommendations. We can also do it remotely, so if you know what your lube list is and your component list is, we've got a match in all probability for what you're seeking. And in terms of, and we provide that service at no additional charge. We also provide oil analysis services to our customers. And for example, we've been on some offshore oil and gas rigs for 14 to 15 years, and we're still doing oil analysis and sampling results on our oil in those systems. So we do offer products, but we also offer services. We do like to think of ourselves as a solutions company. And we do try to technically consult. It's not just about pushing fluids. We want to make sure that you have the right fluid in your application that's going to work and be worry and trouble-free, and we back that with a warranty as well. Here's a question for you, Mark. Do you have or plan to introduce a 2T product for wet exhaust?
We have a two-cycle fluid for small marine outboard products. We do not have a 2T for the major drivers for these types of ships. Okay.
Does the IMO, so that would be International Maritime Organization, currently require similar to the U.S. EPA VGP 2013?
IMO does not mandate the use of environmentally acceptable lubricants. Interestingly, though, from my perspective, is that in their draft guidelines for operations in polar water, they specifically call out that biodegradable non-toxic lubricants are not considered pollutants. Now, the EPA does not acknowledge that. It has not been ratified yet, but I think that declassifying environmentally acceptable lubricants as pollutants will be a major game changer. The IMO does offer certain levels of certification from some of the certification companies for greener ships.
Okay, so here's a tough one. Will RSC Bio Solutions pursue labeling programs certification, so the third-party certifications versus independent laboratory result certification?
We're looking at all various options for certification processes. We are hesitant with some of the European eco-labels due to their mandated levels of bio-based content. We know that there's a significant trade-off in performance as you add in either vegetable triglycerides or synthetic esters. We think that our customers and the industry need high-performing environmentally safe oils and don't necessarily need to have sustainable products. as much as we'd like to have a sustainable product that meets the performance and renewable product, we don't think that there's any product on the market that's capable of doing that at this time.
And the overlay I would have is, since I have responsibility for marketing and sales, when you're talking about the full range of product grades that we offer and the number of labeling programs that exist around the world, I mean, we just named 5 alone in Europe, plus, a couple others emerging in the United States. It's extremely expensive undertaking. So our preferred route is to put forth independent substantiation that we meet all of the requirements for non-sheening as well as ready biodegradation, low toxicity, and no bioaccumulation. In the interim, until sort of everything settles down and there's a clear way forward and a clear preference expressed by the U.S. EPA. And it could be designed for the environment. It's early to tell. But as soon as it becomes more simplistic and probably a little more cost-effective, we're there. But in the meantime, we're able to help through providing letters, testing. It's on our MSDSs, it's on our PDSs, and we're very confident in what we offer by way of certification. Next question. This is another switch the flags question. So Mark, maybe you'll help me with this one. What if you charter a foreign flag vessel that reflags to a U.S. flag and then does trade in U.S. waters? Does the ship owner have to change to an EAL?
As I said before, I'm not positive about that. We could double check with the EPA, and hopefully we have your contact and we'll let you know. But I think that once you start chartering in the U.S., you fall under the vessel general permit, which means you would be needing to file certifications or certificates that say you're not in compliance with the vessel general permit, and then at the next available dry dock, change over to a more environmentally acceptable product and then fall under that compliance. Again, I would recommend, if there's any chance of operating in U.S. waters, it's not that much more expensive. It's a pretty simple application to do, and it's a small environmental or small price to pay over the general cost of operating a vessel.
And with that question, we will conclude our webinar. Thanks, everyone, for the great questions, and I'm glad we were able to provide answers, and thank you for your time and attention, and please do get in touch, and thanks again.
And on behalf of Maritime Reporter, we'd also like to thank you and to Lisa and Mark for presenting, and thanks again for the questions, everyone. Have a good day.